Hi, everyone. We're going to be talking about exponent rules today. And so we're going to be talking about all the different types of exponent rules there are. Starting with the first one, let's take a look at this one. So this is, in this case, if we have a to the m times a to the n, I always like to do examples, right? So let's do one over here. So if we had 2 to the 4th power times, let's go 2 to the 3rd power. Like, what is that going to be? So what does 2 to the 4th power mean in the first place? Remember, that's just 2 times 2 times 2 times 2, right? There's 4 2's, right? 4 2's that we're multiplying. So instead of just writing all this out, 2 times 2 times 2 times 2, we just go 2 to the 4th power. And then we're going to also expand a 2 to the 3rd power, which is going to be 2 times 2 times 2. So we're doing that a total of 3 times. So altogether, how many 2's are we multiplying? We're multiplying, there are 4 here and 3 here, so that's going to make 7. So that's going to make, I'm going to make that green. So it's going to be 2 to the 7th power. So we're saying that this right here is actually equal to 2 to the 7th power, right? Do you guys see a pattern? Yeah, if you notice right here, this exponent, the 4 and the 3, if you add them up, we would get 7, right? Which makes sense because we have 4 2's and then 3 2's, and altogether we would have 7 2's, right? So that would be just 2 to the 7th power. So that product of powers rule, remember power is another way to say exponent, and product means multiply, right? So if we're multiplying a to the m times a to the n, so again, the bases have to be the same. We would get a to the m plus n, okay? So whatever m and n are, m and n are, we're just going to add those up. Okay, so for example, here, instead of having to expand this, I like to imagine in my brain, well, how many 3's do I have? I have 4, right? And then I have 3 squared, so it's another 2, right? So I'm going to add those together, and I have 6 3's altogether. So I'm going to have 3 to the 6th power, okay? If you want to like break it out like that, you can go 3 to the 4 plus 2, right? And then that would be 3 to the 6. We could just write 3 to 6. It's fine. All right, so that's product of powers. I usually don't remember what these names are. I just know what it looks like, and then I just do accordingly. I think about it logically. And so I don't usually remember a lot of these rules. I just think about what they mean and then go from there. So this is power to a power. So we have a to the n, which is a power, and we're going to take that to a power, right? So that's why it's called power to a power. And so a to the n to the m. So that sounds like some kind of rap, I feel like. So let's go like, let's say 3 to the 5th power. Let's just say we're going to take that all to the 3rd power. Right? What does that mean? That means we're going to take this 3 to the 5th and we're going to do that 3 times, right? So this means we're going to do this. So 3 to the 5th times 3 to the 5th times 3 to the 5th. That's what that means, right? And so, which means that we have how many, okay, if I needed to expand it, how many 3's would I have here? I would have 5 3's, right? So I'll just do one, well, maybe I'll do all 3, right? So there's one set here of 5, and I'm going to have another set, right? There's going to be another set of 5, 4 and 5. So again, another set of 5. And then here, this third one, that's going to be the third set of 5. 3, 4, 5. So that altogether, how many 5's? Not 5's. How many 3's do we have, right? We have 15 of them, and I'm sure a lot of you guys were already there where you're like, Miss Lee, there's already 15. You have to write them all out. No, but let me just, for those people who are like to be visual, let me just, highlight these for you because I can. Look at that. All these nice, beautiful colors, right? So there's that group, and then the last group right here, right there. So in essence, what are we doing? We're saying that this is the same thing as 3 to the 15th, right? And so do you see a shortcut way of doing that? Is that a yes? Right, so you see right here, those 5 to the 3rd power, no, 5 to the 3rd, 3 to the 5th power to the 3rd power. So you just multiply those guys and you get 3 to the 15th. just like that. So instead of having to expand all this out, the shortcut way to do that is just, well, multiply them. Okay, but this is the reason why you can, because we have three groups of five. Three groups of 5 threes. Those numbers are a little weird. All right, so let's do this. So again, if we have the basic a to the n to the m, what are we going to do to those, the n and m, and n and m? We're just multiplying them. So it's just going to be n times m, just like the nm or mn. It doesn't matter, right? So in this case, what would we have here? So the quick way of doing that, it would be 5 to the 6 times 2, which would be 12. Most people don't usually have much issue with that one. Okay. So so what we're going to do with this next one was actually we're going to combine these two guys. Well, kind of combine them. Well, a little bit. We'll see how it goes. Okay, so if you see right here, we have a times b, and we're going to take that to the mth power, right? So again, this is a product to a power. Okay, so product to a power, not to be confused with product of powers, right? Because you have a product of two powers, and this here we have a product, two things that are multiplying, and we're taking it all to a power. Okay, so for example here, so if we have, let's use variables this time, right? So we got x times y. So notice we just put it next to each other, and that's x times y. And we're going to take that to the third power. Well, what does that mean? I'm going to just scroll up here a little bit. All right, so that literally means we're going to take xy and we're going to multiply 3 times, right? So it's going to be xy times xy times xy. It's like that. So how many x's do we have? X to the third power, because we got 1, 2, 3 of them. And same thing with the y's, we have 3 of them, so that's going to be y to the third power. If you see, now all of a sudden, okay, remember we don't have any parentheses anymore, and we just have x cubed and then y cubed, right? If you want to think about it, it's kind of like distributing a little bit, right? If you want to think about it like that, some people have likened it to that. So yeah, that's all you get. So well, there's another thing. So what if you have something like here, right? Where you have power and then to a power. So that's kind of like what we did above. So let me do another example. So for example, if we have like, let's say x squared, well, let's do 3x squared. And we'll do that to the fourth power. Okay. So what does that mean? We have, okay, so basically we're going to have this 3x squared how many times? I heard you say it in your head. So we're going to have that 4 times. So 3x squared times 3x squared times 3x squared times 3x squared. Okay, so there's 4 of them, right? And so what we're going to do is we're going to take all these numbers, since we're all multiplying these numbers. So multiply. So 3 times 3 times 3 times 3, right? You'll get used to it. If you keep on doing this, you'll do it really well. So 3 times 3 is 9. And these 3 times 3, that's 9. So 9 times 9 is 81. All right. But for right now's sake, I'm just going to put that 3 to the fourth power. And how many x's do we have? We have 2 here. We have another, so 2, 4, 6, 8. That's going to be x to the 8th power. Okay, again, like think about like distributing, right? So the common mistake here is that a lot of people will say, oh, this is just 3 to the 8th power, 3 times x to the 8th power. Notice that they forgot this 4 altogether. So you do have to, the 4 does apply to the 3 as well. Because anything in the parentheses, that's what's going to be to the fourth power of, right? So we're doing that, multiply it 4 times. So make sure you're not doing that. That's a bad mistake. This is what you want. And technically, we know what 3 to the fourth power is. You can put that in your calculator or, use your fingers. And then that's going to be 81 times x to the 8th power. Just like that. All right, so let's try this one out. So the generic one for this is going to be a to the m times b to the m. Okay. And again, you no longer see the parentheses anymore because we've distributed that m to both of those variables. All right, and again, we're going to do the same thing here using that same idea. So it's going to be 2, we got the same base. 4 to the 5th power is going to be 20. And then 8 to the 3 times 5, that's going to be 15. Ooh. These are really big numbers, and normally with big numbers, we're just going to leave it as in a power form. And yeah, because that's a pretty big number. Okay. And now we're going to do power of a quotient. So basically, we're taking the power to a quotient. A quotient means the result of dividing, right? So let's try this out. I'm going to need some room, so I shall erase some. Oh, do you need that? You could always rewind. Okay. Now, erased. Happy days. And so now we're going to have so for example, if we were going to do, let's say x over 5, let's say, to the third power. Again, this is literally, it's repeating again and again. You just need to know, what does power mean, right? And so we're basically taking whatever's in the parentheses and doing it 3 times, right? So we're going to take x divided by 5 times x divided by 5 times x divided by 5. And I think you already have a good idea of what's going to happen. How many x's do we have? Right, we got 3 of them. And how many 5s do we have that we're multiplying? 5 to the third power. If you want to be fancy, we could even go like this. X cubed over 5 to the third power is 125. Remember, 5 times 5, 25. Plus another 5, not plus, times another 5 is 125. Okay, so that's all we're doing. And notice right here, we've cubed the bottom and we've cubed the top. Basically, cube whatever's inside the parentheses, just like how we did above with product to a power. We cubed everything inside here, the parentheses. That's what it would be. Okay, and so again, what's going to happen with this one? A to the m over b to the m. Okay, a to the m over b to the m. Again, no more parentheses because we've already done all this multiplication in our heads. All right, so this one again, how many 3s are we going to have on top? Yepper dues. We're going to have 7 3s on top. 3 times 3 times 3. 7 times. How many 4s are we going to have on the bottom? We're going to have 7 of them. Can we simplify any of that? Nope. Okay, we're just going to leave it just like that. All right. Ooh. So thus far, if you notice, right, we have A divided by B because that just means that we have 2 separate numbers, 2 different bases. If you notice, this is a little different. You may be like, isn't that the same thing as the power of a quotient? Why do we have that? This is a quotient of powers. I feel like it's wordplay, honestly. A quotient of powers means we have powers that we're dividing, right? Which is slightly different than a power of a quotient. We got a quotient, and then we're dividing that, right? Or we're not a quotient, and then we're taking the power to that, right? Slightly different nuances here. All right. So again, do you need to memorize these words and these terminologies? No, I don't remember these rules. I just think about it logically like this in my brain, and then I do it, right? So we have, so notice right here with the bases are the same. So it's like having 3 to the 10th power over 3 to the 6th power, right? What are we going to have? How many 3s do we have on top? We have 10, right? And so I'm thinking, okay, so I'll literally write it out. Usually I just do this in my head or on my fingers. There's 5, 6, 7, 8, 9, 10. Why did I use 10? I don't know. And then divided by 3 to the 6th. So that means I have 3 or 6 3s. This is my favorite part. So now with dividing, right? I know that 3 divided by 3 is 1. So this is just 1. 3 divided by 3 is 1. So how many of these can I cancel out? I can cancel out. Oop, that goes with this one. I can cancel out exactly 6 of them, right? 10 on top, 6 on the bottom. I can cancel out 6 of them. How many do I have left? I have 4 left on top. Okay, so then this is all we have left is 3 to the 4th power, right? Because those guys right here, they're left on top. Do we need to write over 1? No, because, 3 to the 4th power over 1 is just 3 to the 4th power. right? Anything divided by 1 is just whatever that anything is. Okay, so what did you notice here? Do you see a shortcut way, right? And in class, I would normally, do a couple more so you can see the shortcut way so you can tell me what it is. But obviously, I can't hear you right now. So 3 to the 10th power divided by 3 to the 6th power. See the shortcut way here? Basically, it's like, remember, how many can I cancel out? I can cancel out 6. Then how many do I have left? 4. It's basically finding the difference, right? So it's just 10 minus 6, which would be that 4. Okay. And then so this would be, let's write it out. Assuming that the bases are the same, it would just be m minus n. This should be very reminiscent, right? Because remember what we did in the beginning. When we were multiplying them, what were we doing with the powers? We were adding them. And when we're dividing them, we are subtracting the powers, right? Because we're actually, canceling things out, right? Just like how we did right over here. All right, so if we're going to practice that whole idea, right, this is just going to be what? We have 9 5s on top and we have 7 5s on the bottom. How many of those cancel out? 7 of them cancel out, right? Which means how many 5s are left? There are two 5s left on top. So it's just going to be 5 squared, aka 25. But I'm just going to leave it as squared since this is like our rule sheet, right? All right, so then this goes on with the power of 0. This is the power of nothing, guys, which is a power definitely. Just a little too much. Okay, so if we got the 0 power. So before that, I'm going to just talk about this. If we have 3 to the 4th power divided by 3 to the 4th power, what do we get? We get 3 times 3 times 3 times 3 over 3 times 3 times 3 times 3. And some of you guys are already like, Miss Lee, I already know the answer. Just 1, right? Because anything divided by itself is 1, right? How many times does anything go into itself? 1 time, right? Again, or you can show right here how they all cancel out to just 1 because 3 divided by 3 is 1. So these are all just 1 times 1 times 1 times 1. So this is just 1. But if you remember, we just learned that the quotient of powers, right? What can we do with the m and the n? If the bases are the same, we can subtract them, right? So we know also that 3 to the 4th power over 3 to the 4th power is also equal to 3 to the 4 minus 4, right? For using that rule. And then it'd be 3 to the 0 power, which means, this is what it means, dun, 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 roll please, that 3 to the 0 power is equal to 1, right? We did it 2 different ways, and we found out that, yes, these are just the same thing. So you can do that with any base. Does not matter, right? If we do it like 5 to the 10th power divided by 5 to the 10th power. Anything you do, it's going to always simplify to 1. So basically what we can say here is anything to the 0 power is just 1. So what is 23 to the 0 power? 1. What is Miss Lee to the 0 power? 1. We're all 1. We're all 1, guys. We are the world. All right, now negative powers. This is weird. And some of you guys may have thought this question over here when we're doing quotient of powers. We're like, well, what if the bottom number is bigger? Then what? Okay, so here we go. Here's the answer to that question. So I'm just going to actually, yeah, let me flip those guys. So if we were to have 3 to the 6th power on top over 3 to the 10th power, then what, right? Remember, we have the 3's on top here. We have 6 of them on top, and we have how many on the bottom? 10. Okay, that was a lot. Okay, and then so, and again, remember how many of these cancel out? 2, 3, 4, 5, 6 of them cancel. But what is left on top? This guy right here, right? Because remember, 3 divided by 3 is just 1. So all of these are just 1. So 1 is left on top, and how many do we have left on the bottom? We have 1 over 3 to the 4th power. Okay. So far, so good. Are we all good? So remember, the 3's are left on the bottom. They're not at the top. That's why when we have to have that fraction showing that it's on the bottom instead of the top. All right. And then, but we also know that, remember, what's the rule? That we can actually subtract these guys, right? So 3 to the 6 minus 10, which is, oops, 3 to the 6 minus 10. Remember, look at your number line if you need to. We're at 6 and we go to the left 10, right? What is that? It's going to be negative 4. So we're saying that 3 to the negative 4, this guy right here, is equal to 1 over 3/4. It is not what you thought, right? It doesn't make it negative. It does not make it negative. That's a big mistake, right? It does not make it negative. So 3 to the negative 4 power is equal to 1 over 3/4. You see it? Do you see what's going on here? Right? What do negative powers do? Think about negative means things go lower, right? So this makes it go lower underneath the fraction. Okay, that's what that means, right? Because notice right here we have all these threes left on the bottom. They don't get canceled out, so they just stay on the bottom, right? So as another quick thing like this, it's let's say if we have two or x to the third power over x to the fifth power, right? What's that going to be? We have 3x's on top. We have 5x's on the bottom, which means what? We have 3x's that cancel out, which means what's left on top? A 1. Over how many x's left over? 2. So it's x squared, right? And again, if we were to subtract this, that would have given us just x to the negative 2 power. So we know that the negative 2 means that it's going to be 1 over x squared. So a to the negative 1 just means that it's going to be 1 over a to the 1. Technically, we don't put the 1 in there. We know that a just means a to the 1. Oh, by the way, if you see any x or any variables or even numbers with no exponents, what exponent is that? Right, anything. So if we have like 5, this actually could be written as 5 to the power of 1. Or if we have like 3, that's actually 3 to the power of 1. Or if we have like x, again, x to the power of 1. Do we need to write that all the time? No, we just assume that it's the power of 1 if we don't write anything in there. Okay, so that's just what that is. So 4 to the negative 2 power, again, we don't like to leave things with negative exponents. We want it to always have positive exponents, so it's just going to be 1 over. Remember, the negatives, they bring us down. So it's going to be 4 squared, okay, on the bottom. Okay, and as a little extra, little boost, right? What happens if there's a negative on the bottom? I know some of you guys already asked, right? So if let's say we had like a 3 over x to the negative 2 power on the bottom, then what, right? What do we do? What do you do? Okay, the short answer, there's a long answer and a short answer. The short answer is you just bring it to the top. It's just opposite of where it is at. The 3 has no negative exponent, so we're just going to leave that on top as well. There's just going to be 3x. Okay, that looks really weird. Like it looks like it's in the middle of nowhere. So I'm going to just kind of drag this over here. The beauty of computers, right? Just drag that over like I never made that mistake, right? So yeah, so the 3 just stays because that's not a negative exponent. And then it's just x squared. Bring that to the top. Notice, no more negatives. The long answer to that is on another YouTube channel. No, I'm just kidding. So, okay, you can just stop right here if you want to, but if you want to know the long version of that, the real algebraic version of that, I can just explain it to you like right now. Okay, or you can just stop. Up to you. Okay, so good job, long version people who really want to know why. So remember we said that this is 1 over whatever that is, 1 over this x squared. So this technically should be, I'll write it in a different color, 1 over x squared, right? That's what that would be, right? But remember, so now we have a fraction in a fraction. This is, why I just show you the short version. But there is an easy way to fix this. We're just going to multiply by 1. Okay, remember, if we multiply by 1, am I changing anything? No, it's like makeup. You're not changing the person. You're just changing the way it looks, right? Or not it, he or she, whoever looks, right? So this is just like putting on makeup, right? And we're just multiplying by 1. So what I'm going to do is I'm going to multiply by a very special kind of 1. I'm going to multiply by this denominator. So I'm going to multiply by x squared over x squared. So remember, x squared divided by x squared. What is that? 1. Okay. So when I do that, what happens? This x squared with the bottom one cancel out. That becomes 1, right? And then what do I have that equal to? So 3 times x squared, which is 3x squared. My whole denominator is just now 1, so I don't really need to write it in there. But this is why it just flips to the top, right? Just like this. That's the algebraic reason why that is. Okay, dokies. Do you have to show this work? No, you can just flip it to the top. That's perfect. All right. Well, this was helpful. We have more practice. That's going to be coming up. Look for that video as well. All right. Have a good one.